Hello everyone, I'm Faral Imran and today I'll be telling you a model by Google DeepMind, and this model is known as AlphaProof. And what this model has done, it has achieved silver medal standard in solving international mathematical Olympiad problems. So I'll be telling you all about this. So stay tuned until the end so that you don't miss any information regarding it. So let's get started. So the breakthrough models AlphaProof and AlphaGeometry 2, they solve the advanced reasoning problems in mathematics. So the artificial general intelligence AGI with advanced mathematical reasoning has the potential to unlock new frontiers in science and technology. So Google DeepMind has made a great progress in building AI systems that help mathematicians discover new sites, novel algorithms, and answers to open problems. But how you see that the current AI, they still struggle with solving the journal math problems because of the limitation in reasoning skills and training data. So today they represent AlphaProof, and it's a new reinforcement learning based system. So reinforcement learning, what it does, reinforcement learning is a model which learns through the trials and errors. Means it does makes mistakes and then it learns from it. So it's like learning from the environment. So this is what reinforcement learning is. So it's for formal math reasoning and alpha geometry 2. So alpha geometry 2 is the improved version of geometry solving system, and together these systems they solve the 4 out of 6 problems, and that too from this year's International Mathematical Olympiad IMO, achieving the same level as a silver medalist in the competition for the first time. So, for the first time, the AI has solved the mathematical problems and it has achieved as a silver medalist. So, this is the first time the AI has done the performance in solving complex math problems. So you can see that the IMO is the oldest, largest, and most prestigious competition for young mathematicians, which is held annually since 1959. So each year, what it happens, like the elite pre-college mathematicians, they train sometimes for thousands of hours to solve 6 exceptionally difficult problems in algebra, combinatorics, geometry, and number theory. Like many of the winners of the Fields Medal, one of the highest honors for mathematicians, have represented their country at the IMO. So you can see that this IMO competition has become widely recognized as a grand channel. It's a challenge for machine learning, and even it's a benchmark for measuring an AI system's advanced mathematical reasoning capabilities. So this year, what had happened, they combined the AI systems to the competition problems provided by the IMO organizers. And the solutions were scored according to the IMO's point rewarding rules. So what happened is that an IMO gold medalist and Fields Medal winner, and Dr. Joseph Mears, a two-time IMO gold medalist and chair of the IMO 2024 Problem Selection Committee. So here it is said by Professor Sir Timothy Gowers that the fact that the program can come up with a non obvious construction like this is very impressive and well beyond what I thought was state of the art. So you can see how first the problem was translated into formal mathematical language for the systems to understand, and in the official competition the students they submit answers in 2 sessions of 4.5 hours each. So the system they solved one problem within minutes and took up to 3 days to solve the others. Well, AlphaProof, what it did, it solved two algebra problems and one number theory problem by determining the answer and proving it was correct. And this included the hardest problem in the competition, solved by only 5 contestants at this year's IMO. So alpha geometry true proved the geometry problem while the two combinatorics problems remained unsolved. So here you can even have a look at the score in which the human participation rank, and here this is the system. It has the rank, it has 28 points, which is equal to like a silver, because here you can see it's for the silver medalist. As you can see the graph. So AlphaProof, it's a formal approach to reasoning, and it's a system that trains itself. As I already said, that it's reinforcement learning. So that's why it will learn from the trials and errors. So it will like train itself to prove mathematical statements in the formal language lean, and it also couples a pre-trained language model in with the AlphaZero reinforcement learning algorithm, which previously taught itself how to master the games of chess, shogi, and go. So here you can see like the natural language based approaches can hallucinate plausible but incorrect reasoning steps in solution despite having access to orders of magnitudes more data. So here you can see that when presented with a problem, the alpha proof it generates solution candidates and then it proves or disapproves them by searching over possible proof steps in link. And each proof that was found and verified is used to reinforce AlphaProof's language model, enhancing its ability to solve subsequent and more challenging problems. And if you look at this diagram, so you see here from here till here, this is alpha 0. So this is alpha 0 and this whole is alpha proof, in which there is informal problems that it is formalized. The math problems are formalized. Then the formal problems is like 100 million. There will be a solver network in which it will have give some formal proofs. After that, from these formal proofs, it will again train and then again it will search and give the proofs according to it. So this is the diagram of the alpha proof reinforcement learning training loop, and here you can see like around 1 million informal math problems are translated into a formal math language by a formalizer network. Like from this formalizer network, it is formalized. And then there's a solver network that searches for proofs or disproves the problems, progressively training itself by the AlphaZero algorithm to solve more challenging problems. So here you can see a more competitive alpha geometry 2. So here, as I already said, that alpha geometry 2 is a improved version of alpha geometry. So it's a neurosymbolic hybrid system in which the language model was based on Gemini and it was trained from scratch on an order of magnitude more synthetic data than its predecessor. So this helped the model tackle more challenging geometry problems, including problems about movements of objects and equations of angles, ratio, or distances. So Alpha Geometry 2, it employs a symbolic engine that is 2 orders of magnitude faster than its predecessor. So, when presented with a new problem, a novel knowledge sharing mechanism is used to enable advanced combinations of different search trees to tackle more complex problems. So before this year's competition, so Alpha Geometry 2 could solve like 83% of all historic IMO geometry problems for the past 25 years compared to the 53% rate achieved by its predecessor. So for IMO 2024, Alpha Geometry 2, it solved problem 4 within 19 seconds after receiving its formalization. So this is what it did. And that's all I have to say about alpha proof and alpha geometry. So that is all for my say. Thank you so much.